All right, we'll go ahead and get started, everyone. Thanks for joining us today. We've got a webinar today. It's 2024 IECC Residential Duct System and Duct Testing. What's changed and how we can comply. My name is Randy Plumley. I will be your presenter today. Before we get started, we do have a few housekeeping. This webinar is being recorded. It will be available afterwards, about 72 hours or so. We put it up on YouTube channel. You can find our YouTube channel by just searching Spear on YouTube, or you can go to our website, eepartnership.org. On the homepage, you can click on the news and resources page, and you'll find a link that goes directly to our YouTube channel. So we host over 150 videos covering a wide range of energy codes and HVAC toppings. There's CELC and 515 is on there as well. Today's session is as always, is eligible for IECC or ICC continuing education credits. But to receive those credits, you must be present for at least 75% of the presentation. Within 72 hours or so, you'll receive an email from Kathy Lawrence with a brief course evaluation. Please complete that, return the survey, and once you completed that and return the survey, you'll receive a course completion certificate from Kathy. This will include your course title, ID, and what you'll need to actually report your CEUs to ICC. As always, I'll have the chat feature open. Feel free to ask any questions or if you have any technical difficulties during the presentation. I also have the Q&A feature open as well, so I'm encouraging everyone to submit questions throughout the session. If it pertains to that slide, I will stop, pause, and we'll answer that question. If it's a general question, we'll wait till the end to review the questions at the end. So thanks again for joining us today. Let's get started. Those that are new to Spear, I always like putting this up here. We're a regional energy efficiency organization. We're here to help with adoption or understanding and clarification of the energy code as it pertains to Texas and Oklahoma. If you're studying for the IECC certification, I can also help with test prep with that. If you have questions about the energy code, ASHRAE 90.1, whether you're a plan reviewer, a building official, third-party energy inspector, developer, designer, architect, we're happy to help with any way that we can. We've continued to help cities with their adoptions of the 2021 and 24 now IECC to help understand amendments as other cities in Texas are adopting. They're also putting through amendments. It can get complicated, so we can help others sort through that as it gets adopted. As always, at the end, I'll share my contact information. Feel free to reach out at any time and also share my contact information with anyone that we possibly could help. So significant changes are happening with just the duct system and duct testing. So we'll roll right into that. But why is it important? Why is it still a big deal? We've seen significant improvement over time as code's been updated, but the real gains only happen with enforcement when it requires actual testing. When we test, performance improves, and when we don't, leakage stays high. We did a survey or a field study a while back, and this is some of the pieces from that. But one of the most telling stats we have here basically is about 18% of the homes that met the 2015, back when we did the study, of the Texas Energy Code required 4% duct leakage. That means basically more than 80% of the homes were missing the mark. So if you look at this, you can kind of tell we had several that were not actually meeting that when the study was done for the 2015. The table on the right shows an estimated statewide savings potential. Duct leakage alone represents about 181,000 MMBTUs of potential savings every year in Texas if we've got those ducts tightened up. That's the third highest savings opportunity out of all the measures that were studied during that study. And remember, leaky ductworks directly drive up energy consumption. Even national studies consistently show that duct leakage can waste anywhere from 10 to 30% of the home's heating and cooling energy. Of course, in Texas, we have hot, humid attics for the most part, and those losses are even worse. So when you put all this together, you see a clear performance gap. It has been getting better over time. We still have a lot of cities on the 2015. We have some on the 18, some on the 12, some on the 21. It's a mixture of all, but we still see issues even on the newest code cycles being adopted. We still see issues with duct leakage. So the technology's there to actually prove that we can get those things done, but on the ground performance still is consistently not meeting targets. So that's why the 2024 IECC changes, especially the new leakage tables and clearer testing requirements, are so important. Bottom line, we can get duct systems sealed, tested correctly. The energy and cost savings for Texas homeowners are significant. And of course, comfort benefits are immediate, and something that will be of an attention in later years is comfort, not only just the system and duct leakage, but comfort and imbalances in the house. We'll talk about those a little bit later. So what's changed for the 2024? I just kind of threw this up here. Here are the sections that are kind of new or have been changed or updated. First of all, they have terminology now that says code now consistently uses the word ductwork instead of ducts. That basically is clarified in the definitions in Chapter 2. We have R403.3.1 duct system design. So HVAC systems serving 1 and 2 dwellings have always been required to do manual J and S. And of course, now in the 2024, they've added the manual D is also now required for duct design. Let me back up real quick and just say this. This is what the code book says. This is not what a city and or Texas adopted and or amended. These things could change when an amendment is done and the final draft and the final adoption of a code is done either in a city and or state. I just am basically saying this is what the code book says, and then we take it from there. If you were part of our 2024 residential and commercial basically rollout for the SECO and opening up the public comments, I'm now breaking each of those sections into a lot more detail and slowing it down for the trainings. That's what most of the feedback was, and I appreciate that feedback. It was high level, it was fast, so that's why we're breaking into this. R403.3.2, building cavities. Framing cavities cannot be used as ductwork or plenums. That was basically just changed from ducts to ductwork. R403.3.3, ductwork outside of conditioned space. So now we have a lot of foam encapsulated houses happening in Texas. This better clarifies insulation requirements remain the same as the 2021 for ducts outside of conditioned space. And then ducts in conditioned space, where I was going with that 403.3.4, is when you've got ducts that are now considered in the conditioned space. It's a clearer criteria. There are special rules for attics that has vapor diffusion ports. We probably won't see that in Texas. Leakage to outside must meet a specific item and section, which we'll talk about in a little bit. And then what we may or may not see in Texas happening is there is one called buried ducts. So there are prescriptive allowance and details retained and clarified. Basically, the remainder of the unvented attics using air permeable insulation must meet an IRC level. It basically deals with, like in climate zone 0 through 3A, this option is called out. So buried ducts, deeply buried ducts, recognized higher effective R value when sufficiently buried. There were some people that, as the buried ducts came out, they were doing a much better job by burying it in the insulation. They wanted credit for what they were doing, so the section was created called deeply buried ducts. And then the 403.3.7 duct testing exception returns. Those have been narrowed, so the exception reinstates the entire system in the conditioned space. It also clarifies that if no more than 10 feet of the ductwork is external of that, basically it's not having to be tested, or it is tested, but it's considered in conditioned space with a different target. And then the 403.3.8 is the new table for total duct system leakage. The limits now vary a system configuration. We'll look at the table a little bit later, but it's based on what size is the building or home that's being tested, the number of returns that are on that, and what we go through. But I'm going to mention this real quick because there's still some mention of this in what I see happening around Texas. Is it says there's a total duct leakage, which is known as TDL, and there's a leakage to outside, which is it's also known as LTO. So we'll talk about what those mean a little bit later, and why the LTO is no longer allowed by code. The one big thing now is the 403.3.9 is sampling for multifamily. We talked about it a little bit in our run through with the overall code that we did for SECO, but ducts, blower door, mechanical ventilation now all has a sampling protocol for multifamily. We'll talk about that protocol that's in there and what's listed in the book as sampling and what needs to be done. There's a question here. It says, why are the state codes not enforced in rural areas? That's a great question. The only thing I can say to that is maybe lack of staffing. Most Counties don't adopt an energy code. They do have the allowance by state law that they can, but there's Cameron County, which is the southernmost tip of Texas, has adopted an energy code and has inspectors in the field to do enforcement. But that's the only county that I'm aware of in Texas that actually has adopted an energy code. So that's a great question. I wished it was that way all over. We have had some counties reach out to us about how do we do this and can you walk us through what it means? How do we show compliance, or how does the builder show compliance? What do we need to look for? They're probably not going to have inspectors. It would have to be someone hired as a third party and then reporting back for compliance to the county. But that's not in any place that I've seen except Cameron County in South Texas. So good question. Thank you. Earthwork planning and sizing, we just talked about it a second ago, but manual D is now required. The 2024 is basically saying that they need to be designed and sized using nationally recognized engineering methods, not rule of thumb. Back in the day, and even probably today, we're still doing oversizing of systems and undersizing of ductwork, and it shows that it does not meet the airflow or air balances that we need inside the home. So even though code still says all the way to the 21 manual J and S, in the 24 we now include the manual D. So this section of the 24 tells how the system must be designed, not just installed. The goal is to ensure airflow is balanced. So equipment is properly matched and the system meets comfort and efficiency expectations. So for single family houses, duplexes, the IECC specifically requires duct systems are using the ANSI and ACA and/or ACA Manual D. Manual D takes the heating and cooling loads from the Manual J and the equipments that are selected in the Manual S, and then turns that into a complete duct layout. So that determines duct size based on the actual airflow requirements, the static pressure, the friction loss, the duct material being used, not rules of thumb like all trunks should be 12 inches or all should be 10 inches and then branching off from that. It's basically based on the static pressure being used for design, the friction rates, and then how much airflow is needed to satisfy where it's actually headed. So for systems serving apartments, condos, sleeping units, and multifamily buildings, designers can use Manual D and or recognized engineering methods such as ASHRAE Handbook of Fundamentals or other approved computational methods. So that would be approved by the building official if that deems that they are going to use that and it satisfies the requirement. This flexibility is mainly because multifamily HVACs vary more and have basically more requirements for commercial design tools. So plan reviewers, if you're on here, should also verify that the full manual J, S, and D package is submitted, not just a duct drawing. You need to look for friction rate, available static pressure, room by room airflow. We'll talk about all this later on today. Duct sizes that match the design conditions or design calculations. A distribution, simple layout matching submitted loads. Basically saying this is kind of how my ducts will run. This is how many Ys I have. This is the size of the duct. This is the CFM per room that we're doing. So these documents confirm the system was designed wasn't just guessed or copied from a previous project. It's actually per the project being developed or asked for permit. So a proper designed duct system is one of the biggest factors in passing duct leakage testing and achieving comfort. So when the duct system is wrong, everything downstream becomes harder. Installation, balancing, meeting code testing thresholds, comfort of the home, humidity, all of this is a driving factor that's basically piggybacks on the fact that ductwork has not been designed properly or sized correctly. So that just turns out to say Manual D is the backbone of residential ductwork planning. Without it, everything becomes a guesswork. And then the 2024 IECC making sure that the systems are engineered, not improvised. I like that saying. So they're not guessing at it. They're not improvising while they're in the field. It's actually engineered, designed, and written and documented so that the field guys can follow that plan. This is one that a lot of cities that I see in Texas amend this out or they amend it in some way. Again, this is what the code book says. Take it how you want, and whatever the city that you're going to be building in has a different requirement or an exception. But one of the most important ductwork requirements of the IECC is basically prohibiting the long-standing practice of using framing cavities as returns, pathways, or plenums. Of course, now it says should not be used as ductwork or plenums. That includes supply and return ducts. They must be constructed of a duct material, not framing material. So code language states building framing cavities should not be used as ductwork or plenums. That's both return and supply. This is a firm no on this. So wall cavities, floor cavities, open chases, rim joist spaces cannot be used to move air, whether supply or return. This eliminates a major source of uncontrolled leakage and thermal bypassing inside of the ducts. The reason why that is cavities used as return air pathways or supplies create hidden leakage and pressure imbalances are now created within the system because air is coming from a different place. So when a cavity or floor cavity is used as a return, it's almost impossible for air sealing it. So those things give and take. We see pictures here, and if you put mastic on that, that's great. It's probably going to be a snapshot in time, then it's going to pass, and just as those things start to move, swell, dry, people walking on that, anything, it just starts cracking that. Now we've got leaks inside of that that are uncontrolled. These hidden leaks are basically, they skew the blower door and duct test results because the system is essentially pulling from an unconditioned space. That that goes deeper in what I want to go to here, but if you have a blower door that's failing, sometimes it could be it's being accompanied by severe duct leakage. That's why, again, we don't want building cavities being used as supply and return. So the takeaway basically is all supply and return ducts must be constructed from a listed duct material, not framing cavities. As you see the illustrations on the left, the one on the bottom is basically what I'm assuming to be duct board being built inside of the floor, subfloor opening between framing members. That's the duct, not just using what it shows in the picture above it, which is just capping the bottom with sheet metal or T-ply or sheetrock and then creating that into a return chase. That should not be used. So this ensures ducts are smooth, airtight, durable, and tested. Listed materials include, as we just said, metal duct, flex duct, duct board, approved plenums, not drywall boxes or openings of cavities. So this matches national mechanical codes and supports proper airflow design. Bottom line, framing cavities are not ducts. They're not air barriers. They're not pressure rated. They're not insulated. So the IECC enforces this to prevent hidden leakage, reduce moisture risks, and improve overall HVAC system performance. So again, I'll follow that up with this is what the book says. This is not, I've seen a lot of cities amend this and say you can use it as return, but not supply. So whatever city you're in, make sure that you find out how they've amended this and what they actually are going to require or not allow. So ducts outside of the conditioned space. This kind of basically stays the same from what it was in 2021, but ducts located outside of conditioned space, most commonly in vented attics, crawl space, basements, garages. Whenever ducts are outside the thermal envelope, the insulation requirements become very important because ducts are exposed to extreme temperatures. We know that in Texas is a lot. Main requirement is any ducts over 3 inches in diameter must be an R8. This goes for any pathway prescriptive performance ERI. There are still other above code programmings like Energy Star that can vary this depending on how it's being designed, but this is just what the IECC states. Anything less than 3 inches can be an R6. So for small branches, we've not really ever seen anything less than 3 inches. But basically those are typical short jump ducts or jump runs or small supply for closets. Usually we see a 4-inch in there. That's going to require it to still be an R8. So basically, especially in hot climates like Texas, where temperatures routinely exceed 120 to 140 in an attic, this is where we lose tremendous amount of energy or cooling, conditioning energy to conductive heat inside the attic. So we need that at an R8. For field installation requirements, inspectors should check the labeling on the duct insulation. That's what a third party is required to do. Building officials will do the same. R8 flex duct outer jackets are usually clearly marked. If it's not labeled, treat it as non-compliant because you really don't know. but sometimes it's got a faded label or it's got a mark on it from the manufacturer that's faded. Just make sure that you can try to find that. If you can't, usually ask for that from the installers as a spec sheet from the ductwork. Contractors should avoid, and we'll talk about these later on in the presentation, avoid compression of duct insulation, especially when strapping ducts across framing members, which they should not be in contact with. Compressing the insulation does not maintain its rated R value and could render it non-compliant. Any duct outside conditioned space will lose energy heat unless it is properly insulated. So R8, R6 requirements are straightforward, powerful in reducing HVAC time of run and improve comfort and lowering utility bills. That also is in the prior code cycles. It could be one thing in a crawl space and one thing in an attic. Now it's as long as it's outside of a conditioned space, it has all the same requirements. So we won't go too much into this, but there are some things to bring up because there is a significant change in what people are calling ducts in conditioned space. This is a picture of buried ducts, but if we say that there's a duct in conditioned space because it's inside of a foam encapsulated attic, the 2024 IECC now clarifies what that means. So just because someone says, well, it's an encapsulated attic, so therefore it has to be inside conditioned space, that's a gray area. I've seen a numerous amount of foamed houses where ducts are pushed against the roof deck. It's in contact with the roof deck and then foamed around it. That duct is now outside the conditioned space. So ductwork must be fully on the conditioned side of a thermal envelope. So on this side of the R value required for roof deck insulation. The first requirement is straightforward. So if you're claiming ducts are inside conditioned space, they truly have to be completely inside the thermal envelope, not partially, not mostly, must be fully located in the conditioned boundary. This eliminates the old practice of calling ducts inside conditioned space just because the attic has this says a vapor diffusion port and or it has been encapsulated with foam. Special rules for ducts in vented and unvented attics. Now, if you're doing buried ducts, there are all these rules you can go through. I won't go through all of that. But if you're doing insulation like what you see in this picture, if we start seeing builders trying to use this in Texas as burying ducts in insulation, if it's got a vapor port or it's a vented attic and this is just sitting on the attic floor, then the threshold for testing becomes much smaller. It's 1.5 CFM per 100 square feet instead of what we'll see in the chart in a few minutes. So that is tightened up. So when ducts are buried, something changes. If it's in an encapsulated attic, something changes, and we need to verify those things. So insulation above ducts must meet the calculated R value criteria. The insulation above and around ducts must meet or exceed the ceiling's R value minus whatever insulation is already on the duct itself. This means you can't rely on duct wrap only. The attic insulation has to be substantial enough to thermally protect the ducts. That's where we're going to say, okay, those are conditioned or in a conditioned space. If we just lay the ducts across the insulation and we said, well, it has R8s and there's insulation all around it, that's not meeting the criteria. We cannot call that within conditioned space. So we need to look at some of that. But buried ducts, the one I was going to go through here also, so though we may not see a lot of this happening in Texas, first, all buried ducts must be insulated to an R8. This is if you're burying the ducts. We know that if it's completely inside of a conditioned space, technically doesn't have to be insulated, but this is burying the ducts in insulation. So I'll move to the next. So basically climate zone 0A through 3A in vented and unvented attics. So in hot, humid climates like Texas, supply ducts must now be completely buried inside the insulation, no partial coverage. These ducts must be insulated at least an R13. There's a major change past those versions. There's a question on here. It says 2A says LTO, previous slide, but you said it went away. Yes, so that's a great point. Thanks for bringing that up. I didn't want to spend too much time on buried ducts just because we won't see a lot of it, but the leakage is, and I said a second ago, the leakage that was reduced down to 1.5 is leakage to outside. So doing just a standard duct test, leakage to outside is eliminated. And you can't use that as compliance. Now they've added kind of a wording back into here when you're doing ducts in conditioned space, then you can. Great point, Roger. Thank you. Appreciate that. We'll talk about that more in a minute when we get to the table in just a second. So if air permeable insulation is being used like blown fiberglass, the unvented attic must comply with it's basically the IRC R806.5. This section outlines how to prevent moisture buildup in unvented attic assemblies. We're seeing a lot more of that. There are things in the IRC that aren't in the energy code that talks about how to mitigate moisture buildup, but I'm afraid that a lot of people that are trapping ducts in a encapsulated attic are not taking the extra step to look at how the attic and/or vapor diffusion ports or how attics should be handled to eliminate moisture. It's becoming a little bit of an issue, and we see a lot of claims of having sweating ductwork or possible mold inside the house, and it could be due to trapping ducts in a foamed attic and not treating the attic correctly. So sometimes it's good and easy to actually refer back to an IRC to look at other portions of the book that will help mitigate problems that the IECC may or may not be addressing. So the big takeaway from that is the 2024 IECC brings much clearer requirements for buried ducts. The goal here is simple. So it's reduced duct energy losses while preventing moisture problems in hot, humid climates. So proper insulation level, buried depth, vapor diffusion control are now essential for compliance. I'll still put a caveat at the end that the IECC does not call out for the requirement of a vapor diffusion port or vapor diffusion control. The IRC talks about it, but the IECC does not address that at this time. So just to clarify that part of it. And then, of course, deeply buried. There's provisions for some of that. I won't spend a whole lot of time with that, but the intent here is to give designers credit for the duct systems that they're burying in insulation, enough insulation, so that they perform more like ducts located inside the thermal envelope. So there was a lot of places where they want to claim the effectiveness of an R25 because of how they're blowing insulation over the ducts. So if the ducts are surrounded by blown-in attic insulation and the attic insulation above them is at least an R30, the system can claim an effective duct insulation value of R25. That can help in energy modeling a lot. In addition, the top of the ductwork must be buried by at least 3.5 inches below the top of the insulation level. So these two conditions together create a thermal buffering effect that allows for the code to treat buried ducts as having a higher effective insulation. This was added in the 2024. I like it. It makes sense if people are going above and beyond and trying to get more insulated value for ductwork by burying it deeply in insulation. This is a great way to do it. As I said earlier, we may not see this happening in Texas, but someone may be building a high-performance home and they're trying different things to see if this works. So this is a meaningful new credit for builders in Texas who are already burying ducts. Don't know of anybody that are. It rewards good insulation depth, proper installation, and actually can help meet better ERI targets if that's what you're using to move through the code. And then sealing ductwork and the air handler unit. This is always brought up. I just like to put this on here talking about how these are still being an issue, a point of issue in getting ducts properly sealed. So 403.3.6 spells out what materials and fastening methods are required to properly seal duct systems. The requirements are important because duct leakage levels depend heavily on correct sealing practices. So all tapes mastic used on metal or flex must meet a UL 181B. So UL 181B-FX for flex, approved pressure sensitive tape. Then you've got a 181BM, which is basically the approved mastic. So if this isn't labeled, basically it says it does not comply. So I don't know of any real mastic that's out there. There may be some that are out there that's non-compliant. Everything that I see does have the UL rating on it. But duct connections at the equipment must both be sealed and mechanically fastened. So sealing alone is not enough. So the joint must also be physically secured. So mechanical fasteners on flex duct must comply with 181B and be marked as 181B-C. This ensures strap ties used on flex ducts are approved for HVAC use. And if we're doing anything with round metal duct, basically all the joints need to be crimped, must have at least a 1-inch overlap and be fastened with a minimum of 3 sheet metal screws or rivets evenly spaced around the joint. This prevents joints from separating under pressure when the ducts get pulled, or if they're hanging and starting to pull on the collar. If there's just two on the top and the duct is being pulled up, the bottom will come loose. So most duct feature or duct leakage failures start at improperly sealed or fastened joints. So in using the correct UL listed material and proper mechanical fastening is the foundation for passing duct leakage testing. So I talked about this earlier. I want to go into just a quick difference of what that is. So let's talk about that. So total duct leakage, which is TDL, and then leakage to outside, which is LTO. So on the left side, we see a breakdown of what TDL is. So total duct leakage basically measures everything leaking in the duct system, no matter where the air is going. This test captures leakage into attics, crawl spaces, garages, between floors, wall cavities, even in the conditioned room. So it's performed at 25 pascals with all registered sealed, and the test isolates the duct system itself and the unit and equipment. TDL is the only test method that reflects the actual installation quality of the duct system. Because it's influenced by house leakage or blower door performance, TDL gives consistent, repeatable results. So that is why the IECC now requires TDL for compliance in just about all cases except for what we read earlier. Thanks again, Roger, for pointing that out. The right side is leakage to outside, LTO. So this is what we used to be able to do, and it's no longer allowed in the code itself. But because LTO only measures leakage that escapes to the outside of the conditioned space. With this test, it requires both a duct tester and a blower door running simultaneously. Because the results depend heavily on how tight or how leaky the house is, LTOs often hides real duct leakage issues. For example, in a very tight home, the blower door can artificially mask duct leakage, letting a poor duct system pass. On the other hand, a leaky house can make a good system look worse than it really is. So because of those inconsistencies, LTO made enforcement very difficult. So results varied from house to house, even when they have the identical duct system. So for those reasons alone, LTO is no longer allowed in most IECC compliance pathways. Total duct leakage, TDL, aligns with the ResNet ICC 380, which is the standard that the ICC or IECC follows. It is more reflective of true workmanship, and it's the basis for setting new 2024 leakage thresholds. LTO had too much variability and too many false passes and fails. So the code moved on from that and basically just goes straight to a total duct leakage only as being allowed. So in the testing on this part of it, I'm just going to go, this is what the book says we have to do when we go to set up a duct test. So basically testing requirements is, first, every duct system must be tested to total duct leakage, TDL, not leakage to outside. We just talked about that. That's new language reinforcing testing the entire system. All the tests have to be performed at 25 pascals across the whole duct system. And the leakage number must include both supply and return. So when a result is done on a compliance form, it includes both supply and return. The party performing the test, usually a third party, must provide a written report to the code official. This helps standardize documentation and close out the permit records. So testing is allowed at rough and or final post-construction. The code is flexible on whether registers and grills are installed. The key is whatever is installed, basically you need to seal it. So we need to tape those things up. So you'll either see it being taped up at time of pre-drywall for testing at rough in, or you may not see the tape if they're in and out doing duct testing at final. So there are exceptions when testing is not required. So if it's a ventilation only duct and not part of the system, the HVAC system, it is exempt. Duct systems that are entirely in the conditioned space has a different target, but to be, as we talked about earlier, be considered in the conditioned space. Basically, it says you need to have no more than 10 feet is outside of the conditioned space. This is kind of clarifying as to, well, what if we have just a duct that bends in and out over a patio and comes back? If it's less than 10 feet, we still consider all of it in conditioned space. Therefore, we have a different testing allowance or leakage allowance to actually meet. And then also ensure that no building cavity plenums or gypsum board plenums are done. We're not using building cavities. If the equipment is not installed, we did this through COVID when there was a lot of equipment shortage, but when there's no equipment installed, your testing goes to a stricter limit of 3 CFM per 100 square feet of conditioned floor area. We'll see that in the table in just a second. We talked about it briefly, but multifamily sampling, there is a sampling protocol for that. It's not requiring every single test, but basically it relies on a protocol that we'll see in another slide in just a second. The big takeaway, though, is basically the 2024 makes duct testing clearer, more consistent, harder to bypass. So if a system isn't truly inside the conditioned space, it's going to be required a total duct leakage. It can't do the leakage to outside like we saw earlier. It's going to have to be listed as it's not 100% inside conditioned space. This is the new table for duct leakage. So one of the biggest changes is adding this. Instead of saying 4 CFM per 100 square feet rule, basically it says this is all based on certain criteria. So starting with the purpose of the table, this table sets the minimum duct leakage for TDL, total duct leakage, based on the equipment configuration, whether it's installed or not, and then how the system is installed, time of testing. It replaces the old 4 CFM per 100 square feet, which is a simple but does not reflect real world HVAC designs. This is where going through the code and having more stakeholders involved in getting the code written actually had smart things to say to be able to get things changed in the book that helps everybody, in my opinion. So 2 columns here, one for homes that are over 1,000 square feet, which is the one in the middle, and then for homes that are less than 1,000 square feet on the right. So for homes that are 1,000 square feet or more, the leakage allowance is expressed, of course, as always, CFM per 100 square feet. It basically varies based on number of returns. So if there are ducted returns, fewer than 3 or 3 or more returns mean more potential leak pathways, slightly higher allowance. So instead of, as we see here, and this was surprising to me, and I understand why they did this, but instead of 4 CFM, we could potentially be going up to even higher than that because of the amount of returns and size of the home. So small systems, and then of course, on the second one to the right, small systems have a really hard time getting down to 4 CFM per 100 square feet. So let's say it's a 900 square foot cottage, it's got one main return, and you're trying to now get to a 4 CFM per 100 square feet. That target is so tight that even the equipment itself leaks more than that. So they borrowed from Energy Star and said simple leakage limits are expressed now in total CFM, not CFM per 100 square feet. Basically, it has 3 limits. No equipment installed, 30. Equipment installed, 40 if it's outside of conditioned space. No equipment installed, but it's inside conditioned space, 60. Equipment installed, but it's also inside conditioned space, it's 80. So that is a big difference, and in my opinion, a very helpful allowance for trying to get small systems and small dwellings to pass. So basically walking through each of these row 1 is the space conditioning equipment. They just show basically what is it? Is it installed? Is it not installed? Is it in conditioned space and installed or not, or is it in conditioned space and not installed? There are different ways to look at that. So if we have one that has more than 3 returns and all systems and air handlers are installed and it is totally 100% inside conditioned space, now we have an allowance as high as 12 CFM per 100 square feet. We haven't seen that in quite some time. It used to be 8 for ducts in conditioned space if all equipment's installed, but now it says if that's 3, less than 3 returns. Anything more than 3 returns, we've gone up to 12. So there are some footnotes to call out here. So footnote B, so you can test without the air handler, but you must test again before occupancy if treating the ducts as inside conditioned space. So there's a B, there's footnote B. Footnote C basically says ducts in the attics with vapor diffusion ports. Again, I'm not sure we'll see that in Texas. Do not automatically count as inside conditioned space. It must meet the requirement of R403.3.4. And then footnote D defines how ducts entirely in conditioned space is determined. And this table rewards tighter duct systems and better duct designs. The more compact systems and fewer ducted returns you have, the easier it is to meet these allowances. Large sprawling systems with multiple returns um, they have higher margins of error and can have a little bit more leakage inside those with more returns. Multifamily sampling, we'll walk through this. It's the exact same thing for blower door, mechanical ventilation, and of course duct testing. So instead of testing every unit, code now allows for a sampling strategy or sampling protocol, but only when building is large enough. We'll talk about that. The same protocol applies for blower door and mechanical ventilation. So for buildings with 8 or more dwelling or sleeping units, we do not have to test every single unit. Instead, we test either 7 units or it says the greater of 7 units or 20% of unit, whichever is higher. The sample group must be representative. In other words, basically, so it is including one top unit, one ground floor unit, one middle floor unit, and then whichever unit has the largest conditioned floor area. This is a base to start with. Some cities will amend this and they will do what they feel is necessary. Some cities say that they want all units tested on the top floor. They don't care about the rest of the sampling. They want all. If that meets your 20%, then you probably got it. But this is what code is saying needs to be done. I encourage all cities that even though you're requiring all top floors to be tested, let's get a representative of all the other units that are out there. So what happens when one fails? So if one is failed, if a duct test is tested and it's failed, first of all, that one needs to be corrected and retested before it can pass. But more importantly, when one unit fails, the code now requires us to expand the sampling by testing 3 additional units, including the one that was just fixed. So this continues until all units in the expanded sample pass. The idea is to catch systematic installation problems early and ensure fixes happen across the building, not just in one unit. So sampling saves time, cost, but it also, if the sample unit doesn't pass, the testing expands quickly and can get expensive. Good duct installation practices up front basically keep this from becoming a problem. So I do have, and I will include a PDF in our survey to you that basically is a checklist for plan reviewers, permit techs, field inspectors, and raters to just easily be able to digest a sampling protocol. So I'll send that with the email that we have for the survey. I just want to also keep in mind, and a caveat of, the sampling group should be selected A, by the building official, or B, by a third party doing compliance testing. The builder, developer, architect, designer, GC, you name it, does not need to select which ones he wants tested. That's a good way to be able to only pass what's being tested and not worry about the rest. It really should be selected by building official and or third party. And a lot of times, once you get used to this as a plan reviewer, you'll want to see what is your sampling protocol for this unit or this project or this building. What is your sampling protocol? So basically, you're listing which units are going to be tested in your sampling protocol. A lot of times, the energy guys will do the com check and they'll run this through and they'll give a list of the units that will be tested. Either that or it just simply says X number of top floor, X number of ground floor, X number of middle floor, and then X number of the largest floored units. And that list, that's my sampling plan. So I'll just reiterate, don't let that be what the builder, developer, architect, or designer, GC, is actually stating that they're going to do. So also put together, which also will include a plan review checklist. So this is kind of what a plan reviewer needs to look for in time of permit. So trying to catch duct system issues on plans to avoid major inspection problems later. So basically design submittals is manual JS and D and a simple duct layout. So they must review, basically it has a complete package, JSD. This ensures the system is size selected and ducts are selected per size correctly. The duct layout is also especially important. It should show the duct location, size, returns, and any proposed attic duct burial details. If the ducts are going to be in a vented attic, reviewers should look for notes about R values and buried ducts. So ducts, basically conditioned space declaring if ducts are inside conditioned space. Next, the plans must clearly state whether ducts are in conditioned space. I can't tell you how many times a res check or was turned in, or an ecotrope model is turned in, and it's just listing attic insulation but it's not, it's talking about R30 and they're going to foam it instead, but they're just putting R30 in the res check. And then you get there and find out ducts are in conditioned space and not, but they're trying to misinterpret that on the energy model. So make sure that it's clearly designating whether or not they'll be in conditioned space or not. If the design is calling for buried ducts or deeply buried, which again we probably won't see in Texas, but you want to know what the duct insulation is and what the insulation that will be surrounding and on top of the ducts are. Those details need to be listed on the plans itself for plan review. And then testing report requirements. Reviewers should verify that builder specifies and or third party is specifying the testing standards. Sometimes they don't list it. They just show a CFM that it's actually tested at. But it should be total duct leakage, not leakage to outside. So since IECC no longer allows LTO in most compliance issues. The plan should also indicate that when the test has occurred, whether it's rough in or post-construction. Rough testing has different leakage thresholds. Sometimes it can. Here lately, now they're all the same. It just, in the older code, it used to be different. Reviewers should also check that the target leakage number from the table, which we just reviewed, 403.3.8, basically ensures that that is meeting that. So is the equipment installed? Is it in conditioned space? How many returns? What's the size of the square footage of the home? To determine, does that actually say that my duct leakage is going to meet the requirement of the table? And any unvented attics with air permeable insulation, as in buried ductwork, basically doing blown fiberglass cellulose, putting ducts in conditioned space, must also meet IRC 806.4. And just notice that those things are listed on the plans. And then plan review, as we always say, is the first line of defense. These items must clearly be documented in the plans. Your field inspections must represent what it is in the plans and permit documents. And then duct leakage testing will go much smoother and produce far fewer surprises if this is done clearly in the plan review in the beginning. And as I said earlier, I'll also include this in our survey email. Last thing I just kind of wanted to go through, we've gone through this before, is we're looking at manual J, S, and D reports. So as we see on the left, that's block loads, that's whole building, not room by room, which is the one in the middle. That middle, that's room by room. And then the one on the right is a simplified ductwork plan. It just shows the supply boots, where they're going to be installed in the room, the number of returns, where the return is located, and then the CF film that's actually being produced or should be produced into those rooms. It's also showing size of boot or size of register that will be in there. And then it's showing the duct size as well. The one thing I do see missing is duct length. But on that part of it, we really need, just by all these that we see on the page, we really need a room by room load in the manual J, not necessarily just a block load. I know a lot of cities just request the inclusion of manual J, but they don't ask for S or D, and I'm assuming a lot of times the J is just a block load for the entire house. Technically, really now when we're verifying manual D, you're going to need to see a room by room load to verify that the manual D is meeting the requirement of the room by room for J to make sure that airflow is getting to where it needs to go. So as a reviewer, you need to verify supply and return locations. Every major room has a supply, especially in bedrooms. The returns must be appropriately located to avoid dead zones. This actually just has a simplified return in the center. It looks like they're also showing on those plans, you see 12 by 8 pass-through vents that are return pathways back to the system for return. So that's a good way for that to be done. Let's see, we've got a question on here. Should CFM be tested per supply? I wish that was part of code, Robert, but it is not. Right now, code does not require air balancing to be done. Technically, an HVAC guy should, kind of, in my opinion, to do proper installation, record, and test and record the CFM and meeting the loads for manual J and also meeting what the manual D says, but right now that is not part of the IECC to be done. I don't think it's also part of the IMC either. So good question, I appreciate that. And then of course, as we said earlier, duct sizes and airflow values for each one. A trunk and branch layout, that's what this simplified plan is. We see the size of the trunk and then the size of each branch. We also do see little triangles for probably, hopefully there'll be some kind of Y. They won't be just a duct board triangle, but it probably is. And then the one that's actually at the bottom looks like it's going to be kind of another plenum. It's going to be branched off from there as another plenum. So just making sure those things are due. Note that if there's any duct barrel details or buried ducts, that also needs to be on that. Uh, Together, all three of these documents allow for plan reviewer to confirm that the HVAC system is sized, selected, and designed correctly. There's We've talked about this in previous webinars that I've done, but it's super easy to assume that ducts being of a specific size can carry a specific amount of CFM. It can if they're installed per the manufacturer's instructions. When it's not, you have friction loss, you have turbulence, you have buildup of static pressure inside the ductwork that basically looks like, from a, as Robert just said, if we test the CFM, where did the air go? The ducts pass the duct test because there's not a lot of leakage, but why am I not getting the CFM that I need? Where is that CFM going? A lot of times it's trapped in the duct system, and that's what comes down to proper duct installation. And we'll see pictures of those in just a second. Another quick field inspection checklist. Basically, I'm also going to include this in with the survey email as well. But before drywall and rough-in stage, basically before ducts get buried behind drywall, inspectors should confirm that all joints, seams, connections are sealed using 181 rated mastic or tapes. Check that the air handler cabinet is sealed as well, including the return plenum and any filter boxes that are there. And then this is your best time and sometimes only chance to see all of the duct system in its entirety. I walked a house over the weekend that basically looked like it was pretty much finished for duct system. It was a trunk and branch, and if the duct system was tested, it probably would have passed. However, one of them wasn't even connected to the trunk. So eventually they'll have to cut sheetrock. We found it, told the builder he's going to get that fixed, but it was hiding in a valley of a floor truss system. You couldn't even really see it unless you saw it from a certain angle. So the duct was not connected, which means the leakage won't be seen on a duct test, but eventually someone will say there's no air coming out of this supply. And the only way to fix that is to cut sheetrock and now cut through the trunk and add the duct. So verifying all those things while you're walking, an inspection in the field. Conditioned space claims. So if the contractor is saying that they're all in conditioned space, as we talked about earlier, are they all in conditioned space? It must be on the conditioned side of the insulated thermal envelope. Period. It should not be pushed against outer air barriers. It should not be pushed against decking board and then foamed around it. That is now considered outside of conditioned space. So to claim it's fully in conditioned space, we must verify that it is not in contact with the thermal envelope or the outermost air barrier. So any section that's left in the attic, the garage, the vented crawl space, any place like that, it can invalidate the claim if it is not fully inside the conditioned side of the thermal envelope. And then testing documentation. So once duct leakage is testing and incomplete, inspect the test report closely. So check for, most reports may not say this. There are now, each of the manufacturer of equipment that does duct testing can be connected to an electronic device that will print off a report once it's tested. On that report should list a calibrated date for the gauges. The gauges must be calibrated annually in a field inspection calibration, and then it also must be calibrated either every 2 years or by 4 years by the manufacturer. So the calibration date you normally see on the report will be the manufacturer's calibration date. When was it last verified by the manufacturer? Then it look at the test pressure that it's actually 25 pascals because that's the requirement. Measured fans airflow basically in CFM. So what was the CFM? But that doesn't tell you whether it passed or failed. What you really want to see is what's the CFM per 100 square feet, not just what's the CFM that was tested. A lot of forms that I do see from the city still just say CFM. Well, then the city building official will have to do the calculation to try to find out, does it actually meet that target? So now with the new table that we have, it's going to be very important to now say, what was the CFM per 100 square feet, not just what was the CFM. List the condition floor area being served, the number of returns that system has. So the target and table that we saw with targets there is listed for number of returns for the house, but you kind of want to know, well, what system, on that one system that you just tested, how many returns did that have? And then, of course, whether the pass or fail results matches the, as we just said, the row on that table. There's another question here. Please clarify if sprayed foamed attic using ERI performance, I cannot use R6 ducts. So if you're using, if they're, it goes back to, and this is why it was clarified, great question, Dave. If it's foam encapsulated house, regardless of ERI performance or prescriptive, if they're claiming it's in conditioned space, they don't even really have to be insulated because they're fully inside conditioned space. However, they cannot be in contact with the outermost air barrier. They must be on the conditioned side of the thermal boundary, which is the insulation, to be considered fully in conditioned space. So a lot of them just use for consistency, they'll buy R8 on every home, regardless of how it's being batted, blown, foamed. They'll do the same thing. However, that's kind of an overcost because you don't have to have it R8. It really doesn't have to be R6. It can be metal ducts that are uninsulated. Not really recommended in Texas due to humidity issues that we will still have in a foam encapsulated attic. So using R6 would be recommended. So I hope that clarifies that. If not, please help me clarify that in the question. But I appreciate the question. Thank you. And then a surprising number of test reports could possibly fail because they're using the wrong row on the table. So this checklist will basically help ensure that field inspectors align the design documents and duct leakage test results. Hopefully most of your building officials now will have electronic documents that they can view in the field. This is kind of going to be helpful for when you walk the site and you want to check to see are they installing what they're claiming, and that way you know that the testing testing results listed on the compliance form is adequate. So catching problems early, of course, prevents failed final inspections and saves everyone time and money. So I'll include this checklist on the email. And then just some pictures from the field. I've talked about these before, prior, basically just talking about what we need to see in best practices. But ACCA also calls out this is how it should be done. If you read code, it says must follow manufacturer's instructions. If you go to the manufacturer, it says see the ACCA standards. If you go to ACCA standards, this is kind of what they talk about. So the four big S's that we need to see from flex duct out in the field is smooth, sealed, straight as possible, and then separated, especially in warm, humid climates. They should not be in contact with framing members. They should not be in contact with each other. They should be separated. I don't care if it's just a quarter of an inch or a half inch. It should be separated, not to gain or lose conditioned air inside the duct due to conductivity through the duct itself. So this is what we talked about earlier, just looking at ductwork. So running through subfloors. I know it's in conditioned space. We're not really looking for it to be insulated, but they're using the same flex duct they do in the attic, and then they're trying to cram it through a small opening in a truss floor system, or even TJIs, and they're trying to drill holes and cut through it and try to cram the duct between it. Doing this is going to increase friction loss, increase turbulence inside the duct. There will be airflow issue problems. There will be comfort issue problems. There may be humidity issue problems. The system will have to work harder to overcome this higher static pressure. It will cause a premature failure. So it just will compound on itself over and over and over. And so this that we see on the left was actually done on site. I was part of this. We actually had it tested, and we were able to prove at the end that we were losing anywhere from 30 to 50% of the airflow, about 30% on the supply side and 50% on the return side. If you were part of that webinar, you've already seen the results from that. This is why it comes from things like this. And of course, excessive bends. This one, I don't know if this is, I took this off the internet. Don't know if it was true to life or real. I'm sure it is. But the way that duct is just folded over is going to cause airflow problems no matter how you cut it. Also, items just being spliced into others. We still continue to see cut and stab tees. So just cutting a hole in the side of the ductwork. Here they've basically crushed all of the outer insulation all the way around it by securing the tape. I understand the tape's 181. It's approved, but you're crushing all the insulation. That's a point of um, basically not air, but temperature and heat fluctuations inside the ductwork will happen right there. If not, probably also condensation will happen right there. If you take a stick and kind of lift up on it, realize there's no metal in it, that's because they just cut and stab without a fitting. That should not be allowed. It should be properly fitted with T's or splitters or Y's and then properly sealed and not just cut off to the side. Field verification item still, wires running through returns. That to me, whether it's a fire hazard or not, whether the fire marshal will call it out or not really sure. If anybody's familiar with the wiring that we see here, when it does, or if it does overheat or smoke, it does produce toxic chemicals that actually now will make it back in the return. So really not a good idea to go through returns. You see the red arrow at the very bottom. That's showing that the return box has been lifted up to allow wire to go under it. Really should just go around it. I don't know why they didn't allow enough wiring to where we could just go around it. There was enough space there. Don't know who was there first, electrician or HVAC, not sure. And then on the right, we see lack of mastic. Clearly, if we roll the insulation back, which some cities in Texas require insulation to be left off to see the collars and the connections and the fittings to make sure that it has mastic. But in this case, it has mastic, it's just not in the right place. So we need to have mastic on the collars, on the boots, on the fittings, on the Ys, on the Ts, and then put the inner liner on it, not put mastic on the outside of the liner to look like and appear that it has been mastic. And that still is seen a lot in the field in Texas. And then what effects does the poor installation have for airflow? We talked about that just a second ago. First of all, I want to point out the one that's on the far left is a blown attic. I get it. But this is a good example of we shouldn't see this in a blown attic insulated attic anyways. It should not have a duct in contact with the roofing deck, period. I don't know how you cut it other than the fact that you just don't leave it in contact. But if we're looking at a foamed house, we should definitely not see that because now it's outside the conditioned space. And then crushing the outer insulation with the straps. Most cities don't require saddles. I hope one day that that's in the code. Right now it just says use the approved strapping material, which has gone to a 2-inch wide strap, not a 1.5. That's the correct strap that we're looking at. It's not a noose style, it's just a sling, which is acceptable, but for some reason it has heavily crushed the outer insulation of the duct. And then on the right we see sagging ductwork. We should not see more than a 1/2 inch every foot, so basically 2 inches per every 4 feet sagging. That's way more than that. We should have another strap. Looks like there was another strap at one point. Somebody either cut it or it broke, hanging off the ceiling rafters there. But that should be, even though it's in a encapsulated attic, airflow problems can arise from having sagging ductwork. It could also build condensation at that low point as well, and we've seen that happen. Poorly installed bins, it can be done with additional strapping and actually making a sweeping turn or sweeping bend. Here we see they just put one strap and then let it fall over on that strap. A, it crushes the outer insulation, and B, it causes airflow problems within the inner liner of the duct. So another thing to look for when you're in the field. Same thing with this. The one on the left should actually have the minimum of 2 straps. I know it's a strap every 4 feet, but if you've got a 90-degree bend, let's put a strap on at least before and after that 90 and hold that to a sweeping turn, not a sharp bend like what we see in the one on the right is just a very sharp bend. Push it all the way to the attic itself and then drop it all the way down. That strap could have been much, much longer and allow for that bend to be less. Kind of like this. This is the best way to do it. So the one you see on the right-hand side basically has 4-foot span. There's 2 there. These do have saddles. And then the one right in the middle is an additional one to actually support the sweeping bend instead of actually having sharp bends. The one on the left is just a sweeping bend in a floor system, which is correct and the right way to do that. Great examples that it can be done correctly and should be done correctly. So that's great. And then kind of one last thing I want to show, there's two more here, but just having noose style straps. We see the one right in the far, it's like the center right one. It's been tied as a noose. It's not a sling. Most of those are tied in a noose. You're just crushing all of the surrounding bands of that insulation. The one that's on the left lower side is more of a saddle or strapping, but it's still crushing that. I talked about this over a weekend training that I did in South Padre, but basically it was if we were small enough to walk that duct and we had IR cameras, which a lot of the third parties do, and real estate inspectors have IR cameras, but if we were small enough, or if we had a IR scope that we can run down the ductwork. In a hot attic in Texas like this one we see in this picture, we will see every single one of those straps. Just like we see when we see a house without continuous insulation, you see every stud. What is that? That's a thermal bridge directly inside the house, bringing heat faster through a conductive material. If you go through this duct and you look at it, even though it's still insulated, the insulation is crushed. That increases the heat being gained through that on every single point. So that's just about every 4 feet. But if you look in the far side of that picture, right in the middle, they're using multiple layer of strap in a saddle configuration, not having the problem they see here in the supply. My assumption is the furthest one out is a return, in my opinion, far less of an issue than what we see on the supply duct that's right here in front of us. So we need to make sure those are not over tightened, because that will build up more heat in the duct. The system will produce 55-degree temperature, and at the supply vent, you're only getting 67. That's going to be contributed by this. Things like this, sharp bends, kinks, laying against framing members, touching roofing decks, overstrapping of the insulation, all increases temperature running down the duct. So now we're not worried about how much CFM, we're worried about the fact that we are overheating that air before it gets to the house. So things like this happen all the time. And don't forget, mechanical ventilation, 9 times out of 10, these are tied to the return plenum, which means they are part of the duct system. They do have to follow the same requirements of ACCA for installation. They also have to be part of the testing. So we need to make sure that these are being handled properly as well. So now that the 2021 and beyond requires mechanical ventilation to be tested for proper CFM, installing ducts like this because you don't think that it matters, you'll have a problem with CFM. And you will have failures where you shouldn't have failures, because the box on the right can do what it's supposed to do by ramping up or down and being set at different settings. The one on the left is the Honeywell Y8150. It's a big duct. That may actually be a blowback duct. I'm not sure. That was just one I grabbed off of some pictures that I had. But even if that's not, if that's a supply or mechanical ventilation duct, then we're going to have airflow issues, and we're going to try to get a test number to that that's going to be around the target for the house. And it's going to be harder to do if you have ducts that are ran like that. That just need to make sure that those things are not completely failing as well, just because it's a mechanical ventilation and it's a in most opinions, it's an afterthought of what they're trying to do. We need to make sure those actually are compliant to what's being done as well. So that's all the information I had for this. I appreciate everybody being part of this and on a holiday week. I thank everyone for being present today, but join us on our next one. As I said earlier, I know I went really fast through the SECO presentation. I am breaking each of these sections down, and we're going to go slower, have more detailed information, so you guys can digest what's actually happening, what we're talking about, and what we're doing. And please keep in mind that what I go through is what is in the code book. It is not what's been adopted by local jurisdictions and or state at this point. So as of yesterday, the comment section or comment request time frame was closed for SECO. Now they're going to move that into the ESL's lab with the comments that were made. They'll run some more analysis. They'll bounce it back to SECO, and then hopefully we'll have a decision by sometime next year. But the next one we have coming up, I'm going to go through the 2024 IECC Commercial Mechanical Systems. What's new for Section 403? So if you're a commercial or plan reviewer, commercial guys for plan review, by all means be part of this. We're basically going to look at several key updates for that. So such as Plan review, what affects plan reviews, HVAC design, field inspections. It's basically a practical walkthrough where we just go through and learn new occupied, standby, door interlock control requirements. There are some that have been in the code before. They've changed a little bit. We now have expanded which was introduced in 21, is the demand controlled ventilation has now been expanded with more provisions and space type triggers. There's an updated humidification, dehumidification control limit, especially for horticulture areas. Then there's revised ventilation and exhaust requirements, including dwelling unit systems. There's now a new total system performance ratio, TSPR, compliance option, which may gain some popularity depending on whether everyone can understand how that's being done. And then, of course, key items in plan review and inspectors should verify when the new code comes out. If you haven't and you're not part of our newsletter, hopefully everyone is, you can scan that QR code. It will take you directly to the registration link for this webinar. So that's December 11th at 10:30 a.m. So thank you guys for being here. This is my contact information. Please feel free to share that with anybody. Well, actually, this is not. It's on the next one. This is our main contact. This is our direct number, our website. We're also on Blue Sky. We're on X as EE Partnership, and then we're also on LinkedIn at Spear. So this is my contact information. By all means, snap a picture of this and use this for anyone that may need help with the code. Please pass that along. I'm still listed on SECO's website as the technical advisor for the Energy Code for Texas. Always happy to help. So I appreciate everyone being on here, and thank you guys again for this. I appreciate it. Thank you.